Today we're doing Maths Chapter 14, Linear Programming. Without much ado, let's begin. Now we start with the basic revision. So we know this one, this means, we know this means greater than. When I do like this, like my right hand, if I bend my arm, my right hand, it means greater than. This is a greater than. Greater than. Okay, if I do for the left one, it means lesser than. So this is greater than. Okay, this is greater than, as is seen here. Then if we do one this way, the left arm, like you hold your left arm, this one means lesser than. This one means lesser than. So these are used in inequality. Remember, inequality, lesser than. So we learned these ones in inequality, so we got to apply them here. Lesser than. Then if I do same my right hand, then I draw a line underneath it. It becomes greater than or equal to. Greater than or equal to. Then if I do my same left, the one that looks like my left arm, I do this, it means lesser than or equal to. So these are signs and symbols that are used for inequalities. So first, before we learn the graphy of inequality, let's first of, because linear programming is about graphy inequality. Graphy inequality, that's what linear programming is. So before we do that, let's quickly solve one or two problems in inequality. For example, if we have 15 plus 3x is lesser than 21. It's lesser than 21. So what we do in inequality, we collect like terms. We move this 50 to this side. So we have only 3x on the left side. 3x will be less than 21. 3x will be less than 21. You move 50 to the right. If you move 50 plus 50 from the left to the right, becomes negative 15. Becomes negative 15. Okay, so 21 minus 15, we get what? We get 6. So we say 3x equal to is lesser than 6, not equal to. Remember, this is inequality. We don't use equal to. Okay, we say lesser than 6. So to find x, we have to divide both sides by 3. Divide here by 3 and also divide here by 3, so we can find s easily. So this 3 cancel this 3. Only x remain on the left side. Okay, 3 cancel 3, only x remain on the left side. And then we say that x is lesser than 6 divided by 3, we get 2. So x is less than 2. Okay, we also learned how to represent this in a number line. Right? X is lesser than 2. We can represent it very firmly with a number line. We can just draw our line. We say 1, 2, and 3. So if you say x is lesser than 2, meaning lesser than goes to the left. So we draw the line to the left. Okay, you put the lesser than symbol here, and you put x somewhere here. Or you raise this one up. Another way is to raise this one up, draw it to top. Draw it to top, and go this way. Okay, is another way of doing it. It's up to you the way you want to. You can draw it on the horizontal line directly, or you raise a line up. Okay, so that's for this. That's for this type of inequality. What of this type of inequality? This one is super easy. What you should just do is to cross multiply. Okay, y times 1 is y. And 2 times 3, if you cross multiply this way, 2 times 3 will be greater than or equal to 6. Finish. That's the solution for this. That's the solution for this. So if we want to draw the inequality, we just simply write maybe 5, 6, and 7. 5, 6, and 7. 5, 6, and 7. And we draw our line here on this 5, 6, and 7. These are horizontal line. Okay, don't mind our line, even if it's not straight. Okay, so it's greater than 6, greater than or equal to 6, right? S is greater than 6, so I go up on 6. I draw my circle. Greater than or equal to means we should shade it. Greater than or equal to means we should shade the circle. Means we should shade this circle, and then we go to this side. Okay, this is the inequality for this. But so that's how to do the inequality. But today we're going to look at the graph of inequality. How do we graph inequality? How do you graph inequality? Okay, so we start with the graphing and inequality. The solutions to an inequality can be illustrated in a graph. You can show it in a graph. Now this is how it goes. You say on a pair of axes, shade the region which satisfy the inequality x is greater than or equal to 3. So we're going to have a graph like this one. We're going to have a graph. We label x axis, -2, -1, 0, 1, 2, 3, 4, 5. Then we put x here. We show with an arrow. And then we do y axis, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. You show with an arrow. You put your y axis here. Now remember the inequality says. I think let's make our pen a bit thicker. Okay. The inequality say x is greater than or equal to 3. So when you see greater than or equal to, we're going to use a bold line. You know, a bold line, solid line. So you're going to draw a solid line like this one. Greater than or equal to, you're going to draw a solid line on 3. On 3 on the x-axis. You draw it across 3 on the x-axis. You draw it across 3. If they say y is greater than or equal to 3, we would have drawn the line like this here on the y-axis. So since they say x is greater than or equal to 3, I'm going to draw a solid line. But what if they say x is lesser than or equal to 3? Not less, or s is greater than 3, not greater than or equal to, only greater than. We would have used what? Broken line. Would have used broken line like this. Would have used broken line. So if it's greater than or lesser than, we use broken line. But if it's greater than or equal to or lesser than or equal to, we use a solid line. Is that one clear? Now, where on the graph on the x-axis, where is greater than 3? Anywhere beyond 3, right? Anywhere beyond 3, after 3, everything from 3 onward is greater than 3. So we shade everywhere here from 3 onward, because that's the region that satisfies the inequality. He said we should shade the region which satisfies the inequality. So we shade here. Okay, you shade all here. Because s is greater than or equal to 3. Starting from like 3, you shade everywhere. You shade it, okay? That's the region which satisfies that inequality. So that's the first one we learned. Meaning, that's the first part we learned. Meaning, if they give us an inequality like this, s is greater than or equal to 3, we will shade that region, right? We shade the region. S is greater than or equal to 3. Is that okay? Now let's move on quickly. The next one we have is on a pair of axes, shade the region which satisfies the inequality. Y is less than 5. I told you if it's y, we go to the 5. Since it's only less than, we use broken line. Look at it. Y is less than. They didn't say y is lesser than or equal to 5. They didn't say y is lesser than or equal to 5. If they say lesser than or equal to, we would have used solid line, a solid straight line. But when they say only y is less than 5, we're going to use broken line. Okay, we're going to use broken line. And since it's y, we draw it across the y-axis. This is y-axis, we draw it across y-axis. So we should shade the region where y is less than. Less than 5 is where? Below 5, right? Below 5. If you look at the inequality, it says y is less than 5. Less than 5. Where is less than 5? Below 5. So we shade all of this region. We shade all of this is below 5, is less than 5. Above 5 is greater than 5 is upward. Greater than 5 is upward, okay, on the y-axis. Greater than 5 on the y-axis is everything upward. Everything upward this way. Everything upward is greater than 5. Everything here is less than 5. Okay, y is less than 5 is this way. So you shade everything after drawing the broken line. Why we use broken line, non-solid line? because it's only less than. If they say y is less than or greater than, lesser than or equal to 5, if it's like this, we would have used a solid line on 5. We would have drawn a solid line like this, a solid one. Okay? But since it's only less than, we use broken line, like I said before, we use broken line. And then we shade everywhere below 5. Because you say y is less than 5. This is y-axis. So anywhere less than 5 is below this way. Is that okay? So we already know how to shade on the x-axis, how to draw a line across 3 on the x-axis, and we've also learned how to draw a line across 5 on the y-axis. Now we want to draw like a slope out to the inequality for a slope. So on a pair of axes, shade the region which satisfies this inequality. Okay, when they give us this type, what do we do? How do we get the graph? Because this one is different now. See, this one is not like y is less than 5 or x. You can see x is there, y is there, both of them together. So which means the line must run across x and y axis. Must run across x. So how do we first of all plot this graph? Well, for these ones they are easy because they just say y is less than 5. So on the y-axis, draw a line across 5. A broken line. Okay, for this one, they say x is greater or equal to 3. So x is greater than or equal to 3. Just go to 3 on the x-axis, draw a solid line across it. So these two, the first two, they're easier. But this one now, the third one we're about to look at, it's a bit more complicated. But it's not. What we should learn how to do, graph, how to plot graph, which probably you should have learned in grade 9. So you just draw a table to plot this graph. Assume it's an equality, not inequality. So you put your x here on the table and you get your y value. You can choose values for x-axis. You can choose value from, let's say, -3 to +5 or 6. For x-axis, you can choose value here, -3. Range of value, you choose anything. You can choose 1, 2, 3 to 5. It's up to you. Just choose the range for values of x. Okay, but I'm running from negative to positive. So we have -2, -1, 0, 1, 2, 3. Okay, I stop maybe 3 also. Okay, so we find the y value. If x is 1, -3, y will be what? You say -3 plus 2. That's y will be -1. Y will be -1, right? Then if x is -2, -2 plus 2, you put -2 here. -2 plus 2 is 0, right? So this one will be 0. Y will be 0. If x is -1, you put -1 here. -1 plus 2 is 1. So that's how I get 1 here. If x is 0, you come here, you put 0 here. 0 plus 2, you get 2 here. If x is 1, you come here, 1 plus 2, so you get 3 here. If x is 2, like here, if x is 2, you come here, you put 2 here. 2 plus 2, you get 4 here. The normal way of getting your table of values. If x is 3, come here, put 3 here. 3 plus 2, you get what? 5. So now we got 5. Now let's plot this. Let's assume this is our table and let's plot this. Since it's lesser than or equal to, we're going to draw a solid line. So s is -3. So this is my -3 for x. This is -2. So this is my -3. So my -3, I'll trace y to -1. From my -3, I trace y to -1. That I got my first point here. I get my first point here. Now x is -2, y is 0. X is -2, yeah, -2. Y 0 is here, it's same here, this spot. So you put a point here. Y is 0. Because this is the 0 value for y. It's a coordinate. Each of these x and y is coordinate. Now here, X is -1, y is 1. Here is -1 for x, and y is 1 is here. You mark the point. You mark the point. Right? Then the next one, x is 0, y is 2. X is 0, y is 2. Then the next one, x is 1, y is 3. X is 1, y is 3, trace it to 3. Trace 1 on x-axis, trace it to 3 on y-axis. 3 is here for y. So this is where they meet. It's a coordinate point. You put the point there. Right? The next one, x is 2, y is 4. X is 2, y is 4. Trace 2 on x-axis, trace it to 4 on y-axis. Where they meet, the coordinate point is here. When x is 3, y is what? Y is 5. When x is 3, y is 5. You trace 3 here, trace 5 here, they meet here, coordinate point. You can continue. The next one, when x is 4, y will be 6, right? X is 4, y will be 6. You trace, they meet here. Even though we don't have that value here, I didn't extend. When x is 5, this one will be 7. Trace, they meet here. When x is 6, y will be 8. You trace, they meet here. Then you take a ruler, you draw a solid line. Why solid line? Because it's lesser than or equal to. If it's only lesser than, you use broken line. So you draw a solid line, like what we have already. You draw a solid line. You draw a solid line here. So this you plot the graph. It is after plotting this line, then you begin. They say we should. Remember, they say we should shade the region which satisfy the inequality. Some questions they say leave or shaded the region which satisfy the inequality. They say leave or shaded, meaning don't shade that region, shade the other region. If they are saying leave or shaded, we will not have shaded the bottom side. We will shade this one. We will not have shaded this way, we will shade this way. If they say leave or shaded the region which satisfy the inequality. But if they say shade the region which satisfy, then you shade that region which satisfy. So the question can come in two folds. They can tell you shade the region which satisfy inequality, like what we have in this question, or leave or shaded the region which satisfy the inequality. Okay, now this one, how do we know the regions to shade? We test, we do a test. What do we mean by test? We choose any point on this side, whether it will satisfy this inequality, whether it will obey this inequality. We choose. You can choose here or here, but let's start from this side of this line, this side. And when we say this side, anywhere, you can choose the point here, but this question we chose here, we chose this place. Let me use a different color. Let me use a different color. Oh, the color very varied. Now we chose this point, right? Green. I change it to green. I hope you can see. We choose this point. Now, what's the coordinate value? X is 3, y is 1, right? This point, the coordinate is x is 3 and y is 1. So you got to put it here and see whether it will obey the inequality, whether it satisfies that inequality. Remember, the inequality is y is lesser than or equal to x plus 2. This is the inequality. This is the inequality. Y is lesser than x plus 2. Now the coordinate we chose was x is what? X is 3, right? X is 3 and y is 1. So since y is 1, I put 1 here. I check whether it's going to be lesser than the left side will be lesser than this. And x is 3. 3 plus 2 is what? 5, right? 3 plus 2 is 5. Is 1 not lesser than 5? Y is lesser than 5, right? So because y is lesser than 5, then it means this is the right region which satisfies the inequality. So since they say shade the region which satisfies the inequality, we shade the whole of this side. We shade the whole of this side. Even if I chose this point, even if I choose another point here, don't say, okay, how do I know which point to choose? Just choose anywhere here, choose a coordinate point. Okay, let's choose this one. Even if we choose this one, it will still satisfy the inequality. Let's say I choose a point here. Okay, my x is 4, my y is 3. Now let's substitute it to it. X is 4, y is 3. My y is 3, I put 3 here. 3 is lesser or equal to x is 4. 4 plus 2. Is 3 not lesser than 4 plus 2? 4 plus 2 is 6. 3 is less than 6, right? Which means the point is also, so anywhere here will satisfy, anywhere on this side, any point you choose on this region, this side of this line will satisfy. Even if you choose here, even if you choose here, even if you choose here, anyone, it will satisfy the inequality. So since this question says we should shade the region which satisfy the inequality, we have to shade this region. You have to shade this region. You have to shade this region. But some question can say leave or shaded the region which satisfy the inequality. Meaning don't shade that region. But this question say shade the region. So please, you have to read the question very well. Okay? Because it can come in either of this form. Since they say shade the region, we are shading this region which satisfy the inequality. If they say leave or shaded, we would have shaded here. We would have come to shade this side of the line. Okay? So this is how we do inequality or linear programming. But in exam, we graph all of them in one place. You see these three we do together. Now let's take a look at them, graphing them together. Let's take a look at them by graphing all three together. You see, we grafted them, we put them together. See this one? Another question. X is lesser than or equal to 2. You go to x-axis, draw a line across 2, a solid line, because it's lesser than or equal to. So this is how we draw a line across 2, a solid line across 2 for this one. And because the question says shade the region, you see on the pair of axes, on the same pair of axes, leave or shaded the region which satisfy the inequality. Now, if you look at this one, is leave unshaded. The one we did just now was shade the region which satisfy the inequality. This one says leave or shaded. You say x is lesser than or equal to 2. Where is lesser than or equal to 2? This way, right? Less than 2 is this way, right? Less than 2 is there. Lesser than 2 is this way, right? Less than 2 is this way. So they say leave or shaded. Don't shade that side. Shade the opposite side. Shade what? The opposite side. Shade the opposite side. So we're going to shade this way. Normally, if we follow the first instruction, we should have shaded this way because it's lesser than or equal to 2. But he said we should leave or shaded the region which satisfy the inequality. Meaning shade the opposite region. Shade the other side of the region. Okay, not the region which satisfy. Which region satisfy the inequality? This way. This way is the way that satisfy the inequality. Because you say x is what? Lesser than or equal to 2. So lesser than 2 for x-axis is this way. This whole side. This whole side. But because it's a leave or shaded, we don't shade that region, we shade this other region. We don't shade that region, we shade this other region. Is that okay? Now, the second inequality that we need to graph is y is greater than minus negative 1. Let's go to y-axis. Y-axis is this vertical line, but we're going to draw a broken line across because it's only greater than. It's not greater than or equal to. If it's greater than or equal to, we would have used a solid line. So because it's only greater than minus 1, you go to minus 1 on the y-axis. You go to minus 1 on y-axis and draw a broken line across it. Now, you say y is greater than minus 1. Greater than is above the line, upward. The whole of this up region is the greater than. But why are we not shading that side? Because they say the question says, the instruction says, leave unshaded the region which satisfy the inequality. So we're not going to shade the region which satisfy the inequality. We're going to shade the opposite way. The opposite way is where? This way, the bottom side. So we say leave unshaded the region. Greater than is supposed to be up. Anything above 1, we shade that side. But the instructions say we should leave unshaded the region which satisfy that inequality. So we're going to shade the region which do not satisfy the inequality. Now the third inequality. The third inequality is y is lesser than or equal to 3. Y is what? Lesser than or equal to 3. Y is lesser than or equal to 3. Now, you go to y-axis. Across 3, you're going to draw, because it's lesser than or equal to, you're going to draw a solid line across 3 on y-axis. A solid line across 3 on y-axis. Okay, after that, lesser than is the bottom side. But you say leave or shaded. if you are saying shade the region which satisfy it, would have shaded the downside. We should have shaded. But he said leave unshaded, meaning don't shade that region which satisfy it. Shade the opposite way. So we shade this way, which is not the region which satisfy it. We shade this way. Or like the first question we did. This is question 2, you know, right? This question 2 we're looking at. So you shade, you know, when I mean shade it the way this is shaded in this place. Shade it, not just drawing a line like I'm doing. Shade, okay? Okay, maybe I should have used this shady highlighter. I think this one will be better. Highlighter will be better for shading. Something like the shade it, okay? This is the meaning of shading, okay? Shade it, shade this region. We satisfy this inequality. Which do not satisfy the inequality. Remember, this was a leave or shaded the region which satisfy the inequality. So you don't shade the region which satisfy it. For this question, some question they tell you shade the region which satisfy the inequality, then you shade the bottom side. But this one say leave or shaded the region which satisfy the inequality, so you shade the opposite side. Similarly here, you shade this region. You shade this region. Okay. So there are 3 rules. When do we draw a solid line? When it's only when it's lesser than or equal to, or when it's greater than or equal to, you draw a solid line. That's the first thing you take away from this class today. Another thing you should take away is, okay, when do we shade? Depending on the instruction. If they say shade the region, then you look at the inequality. Which region? If they say shade the region which satisfy the inequality, then you shade upside of this one, because this y is greater than -1. Greater than -1 is up on the y-axis, is up. But since it says leave or shaded, we will not shade this way, shade the bottom side. Okay, the third one is this inequality. Y is lesser than or equal to x plus 2. You know, I have taught how to draw this one. And this is the region which satisfies the inequality. It's the same equation we did before. It's the same equation we did in question 1. And this side is the region which satisfies it. But this one says leave or shaded the region which satisfies it. So we shade this other opposite side. We shade this opposite side. Okay, for this question. It says leave or shaded, so we shade this side. The region which. So most of the exam, I think they normally they use the word leave or shaded or unwanted region. They will say shade your wanted region. This way I'm shading now is your wanted. Where is the wanted? This way. Because, why is it wanted? Because the region will satisfy the inequality. Remember we tested it just now. How to know the region will satisfy the inequality? You choose a point. For this type of line, you choose a point and take the coordinate values as substitute into the inequality and see whether it fits in. Now we graph everything together. You know we have y is lesser than or equal to 2. This is the line. And we shaded this other opposite side. We shaded this other opposite side. Remember that. We're going to graph all of them together. Because in the exam, you graph all of them together in one graph. Not separate graph. Okay? The separate graph we're drawing was for the purpose of teaching or explaining this topic. Okay? So in the exam, each line, each inequality, you put them together, all the inequality, you put them together in one graph paper. Put all of them together in one graph paper. So we shade this way. The region which do not satisfy this inequality. Okay, so we shade this way. Now, for this other inequality, let's take a look at this other inequality. For this one, we say that y was lesser than or equal to 3. So we shade the top. For this one, remember we shade the top because it's your wanted region. They say shade your wanted region, same as leave or shaded the region which satisfy the inequality. It's just English. Okay, you just need to understand. When they say shade your wanted region, you shade where I'm shading now. Or they say leave or shaded the region which satisfy the inequality. So I shade here. Remember for this one, we say this is your wanted region this way. For this line, we shade this way. For this line, we shade this way. For this line, we shade this way. This whole side, we shade it. Okay? Then for this one, this broken line, remember y is greater than minus 1. So we shade the lesser than side, the unwanted side. We shade the unwanted side. Now you see what remains. This is what is used by farmers to know where to plant. If they have to plant so many things in their farmland. Okay, this is what they use to know where they plant, or gardeners, okay, to know, and all business people to know which portion of their land should go for so thing. Okay, so because in inequality there are things you have to know, the constriction or restriction. The constrictions are the inequalities. The constrictions are called the inequalities. The constrictions are the inequalities. So this is, in the exam they may tell you to mark the region which the farmer will plant. So you mark this place, arrow, the region. Okay? Sometimes they ask you to tell the greatest part of the region, the greatest value. So you choose a point, you try the inequality, they will give you equation. And you choose a coordinate point, substitute it to that equation, and see whether that will give the greatest value in that region. So this is the region the farmer may plant on, if this question was about planting. Okay, so this is how we do graphical inequation, or this is how we do linear programming. In linear programming, the question may come, one more question. In linear programming, a linear programming is a way of finding the number of possible solutions to a given problem that has a given number of constraints. What are the constraints? Now we want to look at the constraint. For example, let's take a look at this question. The number of fields a farmer plants with wheat is W, and the number of feet he plants with corn is C. So number of field he plants wheat on is W, and the number of field he plants with corn is C. There are, however, certain constrictions which govern how many fields he can plant of each. There are some constriction or restrictions. Okay? The restrictions or constrictions are conditions. They are called conditions. These are as follows. There must be at least 2 feet of corn. There must be at least 2 feet of corn. This is the condition. At least means what? At least means must be greater than 2. Greater than or equal to 2. So I will write the inequality for corn. I will say C, since they say at least means the minimum. Meaning it can be bigger than that. The minimum. So I will say, because of that, the word at least, I will say greater than or equal to 2. That's the inequality for corn. That's my first inequality. You get it? Then there must be at least 2 feet of wheat. Same thing, at least. So since they use at least for wheat, I will say W must be greater than or equal to 2. Must be great, at least. If they say at most, I will use lesser than or equal to, or maximum. Okay, at least or minimum. When they use the word at least or minimum, means it will be greater than or equal to 2. If they say at most, mean must be lesser than or equal to 2. At most and minimum, at most and maximum, sorry. At most and maximum means it will be lesser than or equal to 2. If they say at most, I would say C is lesser than or equal to 2. At most or maximum, I would say C is lesser than or equal to 2. But the constriction use the word at least. Okay? Then, not more than 10 feet are to be sown with wheat or corn. Wheat or corn, not more than 10. So, should not be more than 10. Meaning this one will be lesser than or equal to 10. Not more than 10. Meaning it should be lesser than or equal to 10 for wheat and this is. So, meaning I'm going to say corn plus wheat equal to 10. This is the inequality. C plus W, corn plus wheat equal to 10. So these are the 3 inequalities I have. The first is to construct 3 inequalities from the information given above. You see, we already constructed the inequality. We've given the 3 inequality. C is greater than or equal to 2, W is greater than or equal to 2, and C plus W is less than or equal to 10, right? This is the first thing. You get your marks, maybe 3 marks for being able to construct these 3 inequalities. You get 3 marks in the exam. The next one, The next one is on one pair of axes, graph the three inequality and leave or shaded. Leave or shaded the region which satisfy the three inequalities simultaneously. Simultaneously means graph them in the same page. Graph all of them together in the same place. Okay? So leave or shaded, meaning we should not shade the region which satisfy it. So we're going to plot a graph like we did here. We're going to plot a graph. We put width. You can put anyone anywhere. We put W on the y-axis and we put C on the x-axis. Right? Now we draw across to, remember C. Let's do for C for con. For con, the inequality is that C is greater than or equal to 2. So meaning I'm going to draw a solid line. Because it's greater than or equal to 2. So on C, look at this C axis. The value on 2, draw a solid line across it. You say C is greater than or equal to 2. So we should have shaded here if they wanted if they wanted us to shade the wanted region or the region which satisfies the inequality. Because you say C is greater than 2. Greater than 2 is this way. Is on the right side of this solid line. But they say we should leave or shade there. So don't shade this way. We definitely go to shade here. We definitely go to shade the opposite way. We shade here. Let's change the color for shading. We can look at the color that looks like this one. Okay. We shade this way, right? We shade this way. We shade this way. Okay, we should not shade above here. It's a mistake. So let's be starting from here and going back. We shade this way. We shade this way. Okay, we shade this way. Because C is greater than or equal to 2. So we shade the lesser that side. We shade the smaller side. Greater than 2 is this way. So we don't shade it. Say leave or shaded. Don't shade that side, the region which satisfy the inequality. You shade the opposite region. You shade the opposite region. You don't shade the region which satisfy the inequality. Is that okay? That's the first one. The second one is W is greater than or equal to 2 also. So this is the W axis. You go to 2, draw a solid line. And then when we draw a solid line, we shade. Because why we shade it down? Because greater than is this way, up way. Greater than 2 is up. So they say we should leave or shade that region. So we shade the below side, the opposite side. So don't shade the region which satisfies the inequality. You shade the opposite side. So we're going to shade this downside. We shade this downside. We shade this side. This is the region which satisfies the inequality. We shade this side. Is that okay? We shade this side as the region which satisfies the inequality. As the region, this is the region which upside is the region that satisfies the inequality. But they say we should leave that side unshaded. Then we draw this inequality. You know, C plus W is less than or equal to 10. It means, what it means, you're going to draw a line. This one is half. From 10 to 10. 10 on W side to 10 on C side. Okay, the graph was supposed to extend to 10. This line is supposed to extend there to 10 this way. Okay? This line is supposed to extend to 10. Because C plus W equal to 10. If you move W to this side, it will be minus. That's why this will be a negative gradient. This one is a negative gradient. So, if you want to know how to do this, you plot the line graph, like I said. You have C and W, W and C. You make a table and put in the value and plot this one. Okay, but I already know C plus W will be what? Will be a negative gradient like this. Why? Why? Because if you move W to that side, it will be C lesser than or equal to negative W. W will come here as negative value. If you move it to the right, negative W plus 10. So this will be a negative gradient if you plot the line. So if you plot the line, so the line is going to slope like this. You know this is a negative slope. Positive slope will go this way. Positive slope will go this way. Positive slope will go this way. Okay, now you test. You test. You can choose any point to know which will just satisfy the inequality. I can choose this point. If I choose this point for this line, where, you know, every line like this, we have to test the region which satisfies the inequality. Every line like this, you have to test. How to test? You choose any coordinate point. Okay, let's choose a different point because this one X is, C is 4, W is 4. You can use it. Let's use it. You can use it. So you say 4 plus 4. Look at the inequality. 4 plus 4. C is 4, W is 4. 4 plus 4 is lesser or equal to 10. That's correct, right? That's true. Because 4 plus 4 is 8. And 8 is lesser than 10, right? 4 plus 4 is 8. So 8 is lesser or equal to 10. It's not equal to 10, but it's lesser than 10. Since it satisfies that one, it means this is the wanted region. This is the correct region. But they say we should not shade that region. We satisfy that inequality. We go to the opposite region. We go to the other side. Since this is the right region, don't shade it. We shade this region, this other region. We shade this way. The whole of this way. You shade it. Because they say we should leave or shaded the region which satisfies the inequality. This is the region we don't shade it. We shade the opposite region. At the end of the day, you have a space for the farmer to plant his corn and wheat. This space remaining is where the farmer will plant his corn. You shade this one very well, okay? Shade. Don't mind my shading. Yours should be better. Okay? So, the farmer has this region left for him to plant his corn and whatever he is going to plant. Okay, so this is how to do linear programming. So with this, we've come to the end of our today's class. And thank you for joining us.